I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy. Before us, a typical chemistry A-level question on enthalpy change. Calcium carbide reacts with water as shown. The data below, the equations show in kilojoule per mole the standard enthalpies or formation of the compounds involved. Now the equation before us, 1 mole of calcium carbide reacts with 1 mole of water to give you 1 mole of calcium oxide and 1 mole of ethyne. So we are given the enthalpy change of formation values. You are asked to calculate what is the standard enthalpy change of the reaction. So to calculate standard enthalpy change of the reaction will be equal to what? The enthalpy change of formation of the product minus enthalpy change of formation of the reactants products. So enthalpy change of reaction, the product you have minus 635 plus 28228 minus bracket minus 60 plus bracket minus 286. So let me use my calculator now. Minus 635 plus 228. If I'm to use my calculator, you will get minus 407 minus, then we have minus 60 plus minus 286. So you have minus bracket minus 346. So the standard temperature reaction will be equal to minus 407 minus times minus plus 346, which will now be equal to minus 407 plus 346, which will be equal to minus 61 kilojoule per mole. So minus 61 kilojoule per mole. So what is the standard enthalpy change of the reaction shown? The standard enthalpy change of the reaction is minus 61 kilojoule per mole. So the correct answer to this question is what? B. B is the correct answer, which is minus 61 kilojoule per mole. It's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge, any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. Before us, a typical chemistry A-level question on enthalpy change. A student mixed 25 cn cube of 4.0 mole per dn cube hydrochloric acid with an equal volume of 4.00 mole per dn cube sodium hydroxide. The initial temperature of both solutions was 15.0 degrees Celsius. The maximum temperature recorded was 30.0 degrees Celsius. The heat capacity of the final solution can be assumed to be 4.18 joule per Kelvin per gram, and the density of this solution can be assumed to be 1.00 gram per cn cube. Using these results, what is the enthalpy change of neutralization of hydrochloric acid? So you have to calculate the enthalpy change of neutralization of hydrochloric acid. So the first thing you need to do, you have to calculate the quantity of heat that is released. And the quantity of heat released, we use the symbol. Quantity of heat released, Q is equal to what? Mass, which is the mass of the solution, times the specific capacity of water, then times the temperature, change in temperature. So the heat capacity of the final solution, which is 4.18 joule per Kelvin per gram, and the density, we are given the density, so we need to get the mass of the solution. The density of the solution is 1.00 gram. So density is equal to what? Mass over volume. So the mass now will be equal to what? Density times the volume. The volume of the solution is 25 cn cube hydrochloric acid, and also 25 cm cube sodium hydroxide. So the volume of the solution is what? 25 plus what? 25, which is equal to what? 50 cm cube. Because from the question is the question said a student mixed 25 cm cube of 4.00 mole per dm hydrochloric acid with an equal volume of 4.00 mole per dm sodium hydroxide. So the entire volume of the solution is 50 cm cube. So mass now will be equal to what? Density, which is 1 times 50, which will now be equal to what? 50 gram. So the mass of the solution is 50 gram. So to calculate the quantity of heat released will be equal to what? 50 times the specific capacity, which is 4.18, times the temperature change. The initial temperature is 15 and the final temperature is 30. So it will be 30 minus 15. So I have to erase so that I'll have enough space. So let me erase this. So let me erase this so that I'll have enough space. So I'm to use my calculator, which will now be 50 times 4.18 times 15, which will now be equal to 50 times 4.18 times 15, which will now be equal to 3,135 joules. So in kilojoules, so let me make it kilojoules. It will now be, just to convert it to kilojoules, divided by 1,000. So it will now be 3.135 kilojoules. So, but you're asked to calculate what is the enthalpy change of neutralization of hydrochloric acid. Enthalpy change of neutralization of hydrochloric acid will be equal to what? Quantity of heat release divided by the number of moles of hydrochloric acid. So we have to calculate the number of moles of hydrochloric acid. Number of moles is equal to what? C times V over 1,000. C is the concentration of sulfuric acid, which is 4, times the volume is 25, divided by 1,000. 4 times 25 is 100, divided by 1,000, which will now be equal to 0.1 mole. So the quantity of heat released will be 3.135 divided by number of mole is 0.1. So the enthalpy change of neutralization will be equal to 3.135 divided by 0.1, which will now be equal to 31.35 kilojoule per mole. So enthalpy change of neutralization will be equal to what? 31.35 kilojoule per mole. Since it's enthalpy change of neutralization is always exothermic. So it will now be equal to what? Minus 31.4 kilojoule per mole approximately. So the correct answer to this question is what? B. B is the correct answer. So as you can see, it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me and I'll be there for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. Before us, a typical chemistry A-level question on enthalpy change. Nitrogen and oxygen can react together to form nitrogen monoxide, NO. 1 mole of nitrogen reacts with 1 mole of oxygen to give you 2 moles of nitrogen monoxide. The enthalpy change is plus 180 kilojoule per mole. What is the bond energy of the bond between the atoms in nitrogen monoxide? So the first thing we're going to look at, we're given the enthalpy change of the reaction. So we have to calculate what the bond energy of the bond between the atoms in nitrogen monoxide. So enthalpy change of reaction, because here we're going to use average bond energy value. So the enthalpy change of reaction Enthalpy change of reaction will be equal to what? Enthalpy for the word bond broken minus the enthalpy change for what? Bond formed. The bond broken is the reactant, while the bond formed is the product. So we're given the enthalpy change of the reaction. So we now have the bond broken is what? Nitrogen triple bond nitrogen, because we're using the bond average bond energy value plus oxygen double bond oxygen minus 2 bracket what? Nitrogen monoxide. So the bond between nitrogen monoxide we're looking for. So the enthalpy change of reaction is 180. So we now have 180 will be equal to the average bond energy value for nitrogen triple bond nitrogen. I use my data booklet, so you check your data booklet. So nitrogen triple bond nitrogen, you have what? 944. Then plus oxygen double bond oxygen, you have 496 minus what? 2 NO, nitrogen monoxide. So I'm going to use my calculator now. 944 plus 496 equal to 1440. So we now have 180 is equal to 1440 minus 2NO. So this one will come back to this side. 180 minus 1440 will be equal to what? Minus 2NO. So 180 minus 1440 will be equal to minus 1260 will be equal to minus 2NO. So I have to erase so that I'll have enough space. So you have minus 1260 will be equal to minus 2NO. So we want to find the bond energy of the bond between nitrogen atoms. So divide both side by minus 2, divide both side by minus 2. So when you cancel out, this cancel out and this will cancel out. So divided by 2, so you have 630 is equal to what? NO. So the bond energy of the bond energy of the bond between the atoms of NO will be equal to what? 630 kilojoule per mole. 630 kilojoule per mole. So the correct answer to this question, I have to erase this so that there will be space for me to see it. So the correct answer is what? A. A is the correct answer, which is 630 kilojoule per mole. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. Before us, a typical chemistry A-level question on enthalpy change. What is the definition of standard enthalpy change of neutralization? So we are going to look at the options that gives us the correct answer to what standard enthalpy change of neutralization. A. Standard enthalpy change of neutralization when 1 mole of an aqueous acid is neutralized by an aqueous alkali. No, A is not the answer. A is wrong. A is not the answer. Now let's look at B. When 1 mole of an aqueous alkali is neutralized by an aqueous acid. No, B is not the answer. B is wrong. Then C. When 1 mole of an aqueous acid is neutralized by 1 mole of an aqueous alkali. No, C is not the answer. Now let's look at D. When an aqueous acid and an aqueous alkali react to produce 1 mole of water. Yes, D is the correct answer. So when 1 mole of water is formed by the reaction of an acid and an alkali under standard conditions, we call it a standard enthalpy change of neutralization. So when an aqueous acid and an aqueous alkali react to produce 1 mole of water. So it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Before us, a typical chemistry A-level question on enthalpy change. which expression gives the standard enthalpy change of combustion of methane. So to calculate the enthalpy change of combustion of methane, so we have to write the equation for the enthalpy change of combustion of methane. So we have to write the equation. So this is methane. Enthalpy change of combustion is the enthalpy change when 1 mole of a substance is burnt in excess oxygen under standard condition. This is methane reacting with oxygen. So the product will be carbon dioxide and water. So the next thing to do is to balance the equation. Make sure that the equation is balanced. The number of atoms of each of the elements on the reactant and the product must be the same. So carbon is 1, carbon is 1, carbon is balanced. Hydrogen is 4 on the reactant. Hydrogen will have 4 atoms of hydrogen on the reactant and 2 atoms of hydrogen on the product. So we have to add 2 here. So hydrogen is now 4 atoms on the product and 4 atoms on the reactant. Hydrogen is balanced. Oxygen will have 2 atoms of oxygen on the reactant and 4 atoms of oxygen on the product. So I just add 2 here. So oxygen is now balanced. We'll have 4 atoms of oxygen on the reactant and 4 atoms of oxygen on the product. So to calculate the enthalpy change of combustion of methane, standard enthalpy change of combustion of methane will be equal to what? Enthalpy of formation of the product minus enthalpy of formation of the reactant. So standard enthalpy change of combustion will be equal to enthalpy of formation of the product. So we'll have what? It will now be enthalpy of formation of what? Plus 2 times enthalpy of formation of water minus enthalpy of formation of methane. Standard enthalpy of formation. So enthalpy change of combustion, enthalpy of formation of carbon dioxide plus 2 times enthalpy of formation of water minus enthalpy of formation of methane. So want to look at the option now. Enthalpy of formation of carbon dioxide plus 2 times enthalpy of formation of water minus enthalpy of formation of methane. So the correct answer to this question is what? D. D is the correct answer. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. Before us, a typical chemistry A-level question on enthalpy change. Which statement about enthalpy changes is correct? So we're going to consider the options. Now let's look at A. Enthalpy change of reaction are always negative. No, it's not correct. Enthalpy change of reaction can be positive or negative. So A is not the answer. Then let's look at B. Enthalpy change of combustion are always positive. No, A is wrong. Enthalpy change of combustion are always negative. So enthalpy change of combustion are always exothermic. So B is wrong. Now let's look at C. Enthalpy change of formation are always positive. No. Enthalpy change of formation can be positive or negative, but they are usually negative. So C is wrong. Then let's look at D. D should be the correct answer. Enthalpy change of neutralization are always negative. Yes, enthalpy change of neutralization is always what? Exothermic. So they are always negative. So D is the correct answer. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.